Next in the electromagnetic spectrum is visible light. This is the part that our eyes see. Visible radiation is emitted by everything from fireflies to light bulbs to stars. It is used to take photos and used by plants to undergo photosynthesis. So visible light is that part of the electromagnetic spectrum that our eyes can actually detect. It sits exactly between ultraviolet, that we've already discussed, and infrared, which we'll be discussing after this. And we generally split visible light into 7 component colors. Starting from the shortest wavelength, we have violet, indigo, blue, green, yellow, orange, and red. You might have realized that these are in fact the colors of the rainbow, but we will be discussing what makes a rainbow next year. So just like our ears can detect sound waves and we can understand sound waves, our eyes have the same thing. At the back of our eyes, there is a layer called the retina, and it is a sensor that detects light of different wavelengths, as long as they fit between these wavelengths. So roughly, according to this image, between 400 and 665 nanometers. As we said, after visible light, we are going to discuss infrared radiation. Now, we have already discussed this when we talked about heat transfer, where we said infrared radiation is the only way heat can travel through a vacuum. Infrared radiation is otherwise known as heat radiation. This is given out by all objects and you feel it on your skin as radiant heat. Infrared is readily absorbed by all materials and it causes heating. Radiant heaters, those that glow red, use infrared radiation, including toasters and grills. If you have ever taken a good look at a toaster, you would see that it glows red as it works. That is because the filament there would become hot enough for it to both emit heat, but that would cause it to also glow red. Moving on to page 26. Infrared is also used for night vision equipment. This works by detecting the heat radiation given off by all objects, even in the darkness of night, and turning it into an electrical signal which is displayed on a screen as a clear picture. The hotter the object is, the brighter it appears. Police and military use this to spot criminals running away. Those of you who enjoy playing video games, like Call of Duty for example, definitely encountered or used in the game night vision goggles. Now, how do these night vision goggles work? So basically, instead of them detecting the visible light, since it is night and there isn't a lot of light, they would have specialized sensors that detect infrared radiation and then translate it into an image. The picture we have here is a picture of a street, a normal street. This picture was taken with an infrared camera. On the right, we have the scale, okay? So anything that is extremely dark, almost black, dark blue or black, is at roughly 18 degrees Celsius. And anything that is pink or lighter, that would be 32 degrees or higher. So what we're seeing here is that the road, most of the road on the right, is at about 24 degrees. The trees are sheltering and are reducing the heat a bit, so they're even colder. The line we are seeing over here on the left is an indication that that part of the road is under sunlight, so it is getting much warmer. In fact, the street over there and the cars that are in the sun are hotter than 32 degrees, whereas the cars on the right are colder. They're at about 20 to 24 degrees, depending on the area. Now, this car here also has a few parts that are close to 30. That might mean that the car has not cooled down properly since it was parked. Further on to the left, we see the facades of buildings. Parts of them are at 26, 28 and even 30 degrees Celsius. And on the far right, even though they are in the shade, we have two people and we can see their body temperatures, or at least parts of their body, are actually warmer than the rest of the road, even though they are not in direct sunlight. Now the picture we are seeing is from a military use of thermal imaging. Okay, when we have someone further away and he is detecting these 5 people crossing a field. Now, instead of colors, because that can sometimes be too confusing, this type of camera uses one scale. So the hottest parts would be white and the coldest parts will be black. This is an example of what would be used in military situations. Once again, the same thing. From a military application, we can see that the underside of these cars, where the engine lies, are hotter than the parts exposed at the top. Infrared is also used for all the remote controls of televisions, DVDs, and PlayStations. To that we can add air conditioners as well. Also, we have to know that PlayStations nowadays might also use Bluetooth to communicate rather than infrared, but the older versions, yes, used to use infrared. It is ideal for sending harmless signals over short distances without interfering with other radio frequencies, like the television channels. The system that uses infrared to control a television is an extremely common one. If you look closely at any of these remote controls, you will notice that at the top, the part you aim towards your television, for example, there is an LED, but you never see that LED blinking. That is because it is an infrared LED. However, there are ways for us to detect whether that LED is working or not. And we can do this by using a smartphone. Now, as we can see, we are being told a traditional television remote uses infrared light for sending signals to the television set. This infrared light is not visible to our naked eyes, because as we said, our eyes can only detect the visible light part of the spectrum. But a smartphone's camera is indeed sensitive to infrared radiation. Thus, infrared light is visible through it. Okay? Because the sensor of a smartphone camera or any digital camera can also detect a little bit of infrared light. So let's see how we can detect infrared light using a smartphone. Basically, all you have to do is point the video camera towards the smartphone and simply press a button. And as you will see the LED lighting up. Now this can be done with any remote control that has an LED and any other smartphone. Doesn't have to be a modern one. Okay, even older smartphones that had a camera, this will work on them. That is in fact one of the easiest tests to check whether the batteries in your remote are working or not. If no light can be seen when looking at the remote through a smartphone, then the batteries might be drained. Another use for infrared radiation is for security purposes. As we've definitely heard, one of the first symptoms that people were showing if they were suffering from COVID-19 was that they would have a fever. And as you might know, a lot of shops are checking the temperature to see whether visitors to their shop have a fever or not, because if they would have a fever, meaning that if their body's temperature is too hot, then they would not allow them to go in. Now, the system is used very widely in airports. Okay, we have an image here of a device that recognizes and indicates the temperatures of people passing in front of the scanner. As you can see, we have 5 people, and the camera is automatically detecting their body's temperature and displaying it above the number. So there you would definitely have some form of security officer monitoring these temperatures, and if he were to detect somebody having a higher temperature than normal, in this case it would be higher than 37.5 degrees Celsius, then he would ask them to not enter the shop, or in the case of an airport, they would not let him board the plane, as well as applying other security protocols. Now, an interesting thing that has happened recently is that the mobile phone company OnePlus has released the OnePlus 8 Pro. Now, as you know, modern smartphones are starting to have more than one camera at the back, and each camera would be specified to a particular use. For example, one of the cameras would be to take long distance shots, another one would be to take extreme close-ups, another one would have a wider angle, for example. But the OnePlus 8 Pro has something we've never seen on a day-to-day mobile phone. It has a type of camera that can detect infrared radiation. Now, it is doing this. It is detecting infrared radiation so that it could detect the temperature of the colors coming into the other sensors and improve the image quality. However, some users have noticed that they can see through certain items, like we have here on the right. Okay, so the bottom part of the image is a normal photo, okay, of somebody holding a black plastic remote control. The top is of that same remote control, but using that special camera. And as we can see the battery within the camera. Basically, what is happening is that there is a specific type of black plastic that lets infrared pass through it extremely easily, which is why it can be detected by this infrared camera that the mobile has. Other examples are the following. So on the far left, we are seeing somebody hold a common Apple TV unit that is made of the same black plastic that we mentioned. In the middle and on the right, they are using this special camera, which OnePlus is saying is just a filter, okay, called photochrome, that allows you to see through certain parts. Okay, we can see that there is the internal part, which is further in than the rest of the plastic. The same thing over here. So on the left, we have a normal television remote control in black and white. The middle and the right are using this filter, using this camera. And we can see the button pads, we can see the batteries, we can see the electronics, because they are made of this commonly used black type of plastic. Finally, I'm going to add a link in the assignment to this video, in which the creator of the video compares normal footage shown on the right to footage taken by an infrared camera. And he also gives examples of materials that let heat pass through them, that let infrared heat pass through them, and other materials that do not.